Welcome, everyone. In the last video, we explored the concept of data binning. We saw what it is, why it is done, and what some ways are to create bins from our data. In this video, we will put this in practice by implementing 3 data binning strategies. For each of the 3 strategies, we will create 10 buckets so that they can be easily compared and we can easily see their impact on the final data shape. So, without further ado, let's begin. Let's start with the first strategy. In this strategy, we will manually calculate the size of the bins and assign a data point a bin if its value falls within the data bin range. To implement, let's first get a sense of our data. As we run this first cell, we can see that the value of the temperature column varies from just under 5 degrees to around 45 degrees. So to create 10 buckets, the size of each bucket would be roughly 4.5 degrees, which we can round off to 5 degrees for simplicity. With the bucket size decided, assigning a data point to a bucket just requires a series of if statements. In this next cell, we look at each data point, check the bucket it belongs to, and then assign it a categorical value unique to that bucket. Here, as you can see, the categorical values range from T1 for the first bucket to T10 for the last bucket. Depending upon your understanding of your dataset, you can perform this strategy for any number of continuous value columns, but for demonstration purposes, we have kept it to just the temperature and the feel-like column. Also, since the train and the test data should be of the same shape, like before, we will perform this step for both the train and the test set. If we run this and the next cell now, you will see that the temperature and the feel-like values have been converted to categorical values. You will also notice that the distribution of these categorical values is highly skewed, with no T10 value and only 15 T1 values. Let's see if our next strategy can help us better distribute our data points across these 10 categories. This next strategy automates the calculation of bin size. It does this by subtracting the minimum and maximum values for each column and then dividing the result by the number of bins, which is 10 in our case. The steps after this are same as those in the previous strategy. We check if the data point value falls within a bin range, and if it does, we assign it the categorical value associated with that bin. If we run this in the next cell now, we will see that the new bin values have been populated and that the distribution of data points across different categories is much better now. With this, let's look at our final strategy, the quantile binning strategy. This strategy creates bins in such a way that the number of data points in each bin is almost the same, if not same. The implementation of this strategy is slightly more complex, so let's go over this slowly. We start by creating a list of features that we want to create bins for, and then sort their values in ascending order. Next, we calculate the length of this sorted list and use it to calculate index values that would split the data equally. Next, we check the binning values corresponding to these index points, and these binning values are what we are going to be comparing our data points with. We also create a category value list here. With this done, we next start with the actual process of converting continuous values into categorical values. We start by taking our binning list and checking if the data point in question is less than the values in the binning list, and if so, we assign it a value 1, else 0. We then take this list of zeros and ones, find the index where the first one appeared, and then find the categorical value corresponding to that index. Think of it this way. If our actual data point is 12.2 degrees and the binning points are 10, 12, 14, 16, and 18, for example, we would get ones for 14, 16, and 18. But the actual binning point would be 14, or the first value where we got a 1. This is all that we have done in this part. If we run this and the next cell now, you will see that the new bins have been created, and that the distribution of data points in these is almost uniform and much better than the previous 2 strategies. As we mentioned before, the number of bins and the use of a particular binning strategy would depend upon your use case. So give them a try and see if they improve your model's performance. And that is all for this video. In the next video, we will explore data transformation. See you there!